I actually have 5 different categories that I look at.
Mm-hmm.
The first one being the brain. And the first chunk of genes I'm looking for are Alzheimer's risk genes.
Right.
And the interesting thing about those is even if oftentimes Alzheimer's is like the far extreme. It's like if you've gotten to the point where you've got Alzheimer's, you've done something wrong for a lot of years.
Yes.
So usually, in my opinion, you can prevent Alzheimer's if you start real early and doing the right thing in the right way. The problem is there's a lot of different Alzheimer's risks, right? I mean, like you'll see here, there's 5 different categories that I have. Some people get Alzheimer's because they have chronic inflammation.
Mm-hmm.
And there's actually genes in your brain that are involved in clearing inflammatory products and dealing with inflammation in your brain. And that's different from inflammation in your joints and different from other forms of inflammation, right? Sometimes inflammation is very localized. It's not just throughout your whole body. It might just be chronic inflammation in your joints. And then you get a blood test. It doesn't look like you've got inflammation, so you think you're fine.
Right.
Similar with the brain, like for the most part, researchers aren't tapping into your cerebral spinal fluid and checking for inflammatory chemicals that are actually in the fluid in your brain, right? Because you have to tap into your spinal cord to do those studies.
Yeah.
And, that sort of thing. So that's just one category of Alzheimer's. Another risk would be heavy metals, for example, and you don't have any genes in either of these categories. So I'm bringing them up because it's important to know that, like, if you've got a problem clearing heavy metals from your brain,
mm-hmm.
well, then you better be like a lot more proactive about checking for heavy metals. And then if you've got high heavy metals, make sure to get them down, figure out the foods that, there's so many of them. There's cobalt, there's chromium, there's cadmium, there's all kinds of other ones. Just to guess, isn't really an effective strategy for decreasing your heavy metals. You really want to know, and you want to figure it out if you've got those genes.
Yeah, absolutely.
And similar with some of these other categories, right? Like the carbs, the first gene I wanted to bring up was the FOXO3, because some people, they deal really well with carbs, mm-hmm. with their kidneys and their whatever, their liver, but their brain does a really poor job.
Yes.
Right? And then alternatively, some people, their brain does phenomenal with carbs, but their body does really poorly with carbs and they get diabetes or whatever. And then some people just phenomenal with carbs across the board.
Sure.
And that's pretty rare, to be honest. I don't think humans are really designed to eat a high carb diet. I mean,
yeah, me neither.
90+% of people, but you do find that random person that can every once in a while. And usually they think everybody should eat a high carb diet.
Of course.
They don't get fatigued from it or whatever. But for you've got this gene that gives you a lot more brain fog if you've got a high carb diet. Plus it actually leads to Alzheimer's risk.
Okay.
At the end of the day, long term. But even in the short term, like I said, you want to optimize your brain performance. Be careful with carbs, man. I mean, if you're eating, a fair amount of carbs, make sure you're training, right? And burning them,
right.
Putting them into your muscles and all this kind of thing.
Right.
And you've probably experienced that, right? I mean, you probably know if you eat a huge meal with a bunch of carbs, you just want to take a nap.
Yeah, absolutely. 100%. The other question I had here that's a concern for me is I worked with a functional medicine doctor once who looked at this, just my raw data. And he's like, hey, have you ever had any concussions? And I was like, oh boy, because I was a boxer.
Oh, wow.
So I'm like, I don't know. And I was like, I don't know when was a concussion, when wasn't. I know times that, like, my nose was busted open, I'm bleeding. I was like, probably head trauma, like all these different times. So he was just like, okay, like you need to be really careful. He was like, one, don't ever box again. Like you don't want to do that, like sparring and stuff like that. So is that a concern here, having specific genes?
Oh, for sure. Yeah, absolutely. I think the ApoE4 gene would be the biggest concern with the head trauma.
Okay.
Although people kind of debate that. I just gave a talk for the Special Forces. My second talk for them, it was for like 200 leaders in the special operations at one of these military bases. And the whole talk was about brain optimization. It was based on genes because most people are just giving these broad recommendations for everybody. Right. You see guys like Julian Edelman, right? These football players that are just getting banged year after year with their head, just getting crushed, and they keep playing, they keep, performing at a high level. Now, I don't think that's good for anybody, right? But some people can certainly handle it a lot better than other people, and there are genetic differences there.
Well, there are examples of this too. I remember, I think his name was Chris Henry, I want to say, was a Cincinnati Bengals receiver, I believe, who had this big domestic dispute with his wife, and there was an accident and he died. But just a whole lot of anger. WWE superstars like Chris Benoit had this famous like murder suicide of his family, which was crazy. But I know like Chris Henry, Chris Benoit, they do autopsies on these guys.
Yeah, I used to do them. I was involved in that. Yeah, that was my lab in Boston. Oops. When I used to do Alzheimer's research, I was in my lab. It wasn't me. I wasn't leading that lab, but we were in the New York Times. We were on CNN with Sanjay Gupta, all this kind of stuff. And McKee was the one leading the lab. McKee is MCKEE, I think. And I used to go with her every Thursday and do brain cuttings at the morgue. Yeah. And it was all these NFL players that had donated their brains and their families and the boxers. And we even had military people that had they basically had, what you end up getting is plaques in your brain from these concussions. And then when you have Alzheimer's, there's two different kinds of plaques. There's amyloid, like A beta, they call it. And then there's tau, TAU, it's called, tau plaques. And when you have Alzheimer's, you've got both of those generally. But with the concussions, you just generally get the amyloid plaques. It's different. Okay. And it's kind of a long topic. Like we could literally spend a whole podcast talking about this stuff. Right. But the point is, like, for you, I think just looking at your genes, if you had a brain injury, I think you're pretty good, to be honest. You've got excellent genes across the board, really, but especially in the brain category. But if you did have a brain, if you had a concussion, I would say go keto for a while. Okay. And a lot of people say that just as a general, piece of advice. But for you, I don't think that's true for everybody. Yeah, I mean, it might help a little bit for most people, but for you, it's especially important. That would be the big strategy, in my opinion. Okay. Right. But and for people listening, again, that's a plus gene, meaning you got a bad version from your mother and a bad version from your father. Usually if it's a plus minus, it's a lot harder to predict because, the plus minus is meaning you got a good copy from one parent and a bad copy of the gene from the other parent. Sometimes your body kind of, it compensates one way or the other. It just uses the good copy of the gene and it shuts off the bad copy. Your DNA can actually get shut off, turned on and turned off. Sure. But then that's not always true. So like the plus minus genes are harder to predict. But one example of that is BDNF. So you have a gene, a plus minus BDNF gene, that's brain derived neurotrophic factor. And that one, it potentially means you have less BDNF, but it's a plus minus, right? Okay. So it does increase your risk for Alzheimer's a little bit, but at the end of the day, as long as you're exercising, usually you're fine because, but an important caveat is endurance exercise, particularly increases BDNF, whereas heavy lifting doesn't. Interesting. Because I do not do a lot of endurance training. Right. So, well, and you have a plus minus, so it's probably not that important. Okay. And there's a ton of supplements that increase BDNF as well. And I think just eating healthy and just doing all this sort of thing increases BDNF. So, but that's an important thing because, quite a few people have less BDNF and it's associated with lifespan and all this, like it declines as you age. And, it's probably one of the more important components for increasing lifespan. Okay. There's a million things, right? Like the thyroid hormones, they go down as you age. Sure. Like your deep sleep goes down as you age. Like sex hormones go down as you age. There's so many things, but BDNF is one of those things. And it's kind of chicken egg. And like, maybe it's just because people aren't exercising as they age, whatever. But by the way, curcumin also increases BDNF, just the supplement. I saw that in the report. Yeah. But the thing about you is you've got some of these leaky gut genes that we'll talk about later. Yes, I would love to get into that. Yeah, oftentimes, and you have a lot of those. Nice. Compared to most people, but oftentimes curcumin actually is pretty tough on the gut, which is ironic because some people it's really beneficial for their gut because it's anti-inflammatory. So if you have gut issues that are related to inflammation that's flipped off by curcumin, then it's a great thing. But if you've got a sensitive gut and it's not related to that form of those types of inflammation, then curcumin can actually be tough on the intestines. What was interesting too is that you use this example of like inflammation in joints. When I did a Genova Diagnostics, I did a Nutraval and a GI map and found that like if you take my blood markers like homocysteine or C-reactive protein, it's literally like untraceable. Like I'm below reference range. Right.
And then I did the GI map and it was like, you have inflammation in your gut. I'm like, whoa, that's weird. So I have like this localized inflammation in the gut that's not making its way into my bloodstream, I guess, which seems strange.
Yeah. I mean, a lot of times you find like with celiac and things, like people are malnourished basically because their gut in response to some of that inflammation, it actually just shrivels up.
Wow.
Like, and so, you know, sometimes it's not actually leaky. It's actually just tighter than it should be because, you know, you're not getting anything as a response because you don't want to be pumping bad bacteria into your bloodstream, you know?
Yeah.
But
it's like a built-in defense mechanism.
Like if you want, we can jump down there actually, because I mean, the rest of these brain genes are pretty good. You have a couple anxiety genes relating to serotonin, but a lot of people have those and they're usually okay unless you're eating unhealthy and things like this. And you could certainly like take some of the supplements I recommend there if you have anxiety. Thankfully,
I think that's really cool. You have people can see this in the show notes, but a melancholy and an anxiety section.
Yeah,
which is really cool.
Yeah, relating to serotonin production or serotonin uptake in your brain. You have a little bit of both. You know, so you make a little bit less serotonin and you don't bring it up into your brain as much.
Okay.
And so anything to increase serotonin, just before we jump down to the leaky gut section, I mean, 5-HTP is known to increase serotonin, but I like to take that with tryptophan because tryptophan is it's one of the amino acids and it's a building block for serotonin. So you want to give your body the building blocks and then trigger the manufacturing of serotonin.
That's super helpful.
Some people respond differently. Like some people need to try GABA or St. John's wort or something else. Like those ones, serotonin's a tricky one, right? I mean, that's where all these SSRI drugs, these depression drugs and anti-anxiety drugs, they target serotonin, and it's a complicated system.
Yeah.
That's why I give you a few options here because, you know, it can be a tricky system that different people respond differently to those supplements. That's the epigenetic component you were talking about before.
Sure.
But
I had a question here too, real quick. The caffeine metabolism, right? So if we look at this one that I have, caffeine is eliminated by your body more quickly than average. And I see that that's a plus. So is this an example of like plus doesn't necessarily mean bad. It's just you're testing for one specific thing.
Exactly. It's just one of these plus is totally arbitrary.
Gotcha.
So in this case, it actually means your liver enzyme is functioning at a high level. Okay. To break down caffeine. CYP1A2 is the liver enzyme in this case that breaks down caffeine. So yeah, exactly. It just makes sure that I flag that gene for people because some people have, like I was doing a consult with a professional pitcher in baseball, Major League Baseball, and he had 3 anxiety genes all related to caffeine. And a lot of people do. Like there's a lot of people. So to just globally say that caffeine is good for everybody can be a problem if people have a lot of anxiety.
Absolutely.
Because that's just, you know, that can cause inflammation, right? Because there's a lot of stuff going on with anxiety if you got that problem.
Right.
And he knew it. Like he knew that whenever he has caffeine, he gets major anxiety and he's just religious about avoiding it. But some people don't realize that's the trigger in their case. And there's always, that's a really interesting thing to kind of compare and contrast. Like how does your body deal with caffeine in terms of the liver? Like do you break it down really quick? Does it stay in your body a long time? Because the worst combo is when you've got anxiety genes for caffeine, plus it stays in your body a long time.
Right.
For those people, it literally, you can drink 1 cup of coffee and 2 days later, you'll still get anxiety.
Yeah.
Higher level.
Or I mean, I've talked to clients who they're like, no, you don't understand. Like I have a cup of coffee at 8 a.m. and I will not sleep that evening. There's no
exactly.
chance.
That's the anxiety usually, not the caffeine. Yeah. Because if you test their blood, the caffeine's not there. So it's clearly something else.
Right. Which is crazy.
Most doctors will kind of laugh at people like that and say like, oh, you're full of shit. Like it's not actually there. It's just mental. Yeah. Well, in some sense it is mental because you got all this anxiety you've just triggered and that lasts days sometimes.
So that lasts longer than people talk about the half-life of caffeine or whatever. It's like, it's going to last a lot longer.
Exactly.
That's interesting. Yeah. And then it's crazy how individualized it is because the problem that I see is, you know, if you're in this world of health and wellness and you're trying to self-experiment, do all these things, it's like, if you only listen to Dave Asprey's podcast, you will be like, coffee is good for everyone. Everyone must drink coffee, you know? So, and then you'll do it and these little things might creep up and you don't necessarily realize that it's the coffee or caffeine doing it because you've been told all this time that coffee is wonderful for you and people live longer when they drink 6 cups a day, you know?
Right. 100%. And I mean, the same is, it's across the board, man. Like the same is true for diets more so than anything, because there's people that are just religious about like, my diet works better than everybody else's diet.
Exactly.
And it's like, it probably does for you.
Right.
But it probably doesn't for 90% of everybody else. But then what they oftentimes will do is they'll promote that diet being like the ultimate for everybody. And then people will try it. It sucks for them. So they stop doing it. But then other people will try it. A few other people find it successful. So they join the club and then they kind of feed off each other and create that confirmation bias.
Dude, and just how like egotistical is that? Like if your body is not like mine, you're doing it wrong.
Well, and they don't even realize most of the time.
Exactly.
They think they don't understand the genetic variability and the epigenetic variability. Because sometimes people do have the same genes, but that's exactly when the epigenetics can kick in, is like, especially with these sex hormones, right? I mean, that's why I wrote a book on estrogen, because the estrogen in particular, we probably talked about this last podcast, but estrogen crosses into the cell. It goes through the cell membrane, which most hormones don't. Most hormones stay on the outside of the cell and they trigger a response on a receptor. And that receptor, you know, like relays the information, like on a relay race that pass the baton. But estrogen goes right through your cell membrane. It goes into the cell. But not only that, your DNA is protected by a membrane as well, right? You have a nuclear membrane, it's called. It's even more stringent. Like it protects your DNA from getting damaged. Estrogen goes through the DNA membrane as well. It goes directly into your DNA. So it can flip all these genetic switches.
Wow.
And it can get passed on to future generations. Those switches can get flipped and changed and passed on.
Yeah, we talked about that in the last podcast. That's crazy, man.
Exactly.
Scary.
So sometimes what your parents did in their diets actually impacts you in terms of what's better or worse in your case. And that's going to be a big one 10 years from now. People will understand that, hopefully.
Absolutely. Yeah. Well, so let's dig into these, the leaky gut genes. So this is now section 2 of your report, which is diet optimization genes. And now there are a whole bunch of things listed here.